Okay, here in the given question, a plant virus consists of uniform cylindrical particles of 150 angstroms in diameter and 5000 angstroms long. 150 angstroms diameter, 150 angstroms, and length, if you take it, 5000 angstroms. Then they have given the specific volume also. Specific volume of the virus is 0.75 centimeter cube per gram. If the virus is considered to be a single particle, its molecular mass is. So here virus we are taking like single particles and we need to find the molecular mass. So molecular mass of virus, a living being, we are going to find. So volume of single virus, if you take it, a single virus, one virus if you take, volume, since that is in cylindrical shape, what's the cylindrical shape volume? For example, here radius, if I take it r, if I take it circle, area is pi r square, and this cylinder is having some height. So volume of the cylinder is pi r square h. Pi r square h. Now, so if you substitute 3.14 r value, this value is 0.75 centimeter cube per gram. That is 150 angstroms in diameter they have given, and length is 5000 angstroms, means that is literally height. Height is 5000 and diameter is 150 angstroms. So 150 by diameter is equal to 2r, or r is equal to d by 2. So 150 by 2, 75. So how I am writing 75? 75, since that is in angstroms, I am converting into meters, 10 to the power of minus 8. Okay, centimeter cube has given, so centimeter 10 to the power of minus 8 into 5000 into 10 to the power of minus 8. So what the value we get here? So if you simplify, the value is 8.836 into 10 to the power of minus 17 centimeter cube. Now what we are doing, mass, if you are finding mass of single virus, so we got what is the volume. Now mass, if you want to find volume by specific volume, volume by specific volume will give mass of single virus, mass it gives. So 8.836 into 10 to the power of minus 17 by specific volume is 0.75 centimeter cube per gram. Specific volume also like in centimeter cube. So centimeter cube, centimeter cube cancel, you will get in grams. So 8.836. If you calculate 8.836 by 0.75, we get 1.178 into 178 into 10 to the power of minus 16 grams. Now mass of single virus we got. Now mass of 1 mole of virus, or you can say 1 mole of virus or molar mass of virus. Molar mass of virus. So what we have to do, 1.178 into 10 to the power of minus 16 into Avogadro number 6.023 into 10 to the power of 23 viruses are there in 1 mole. So we will get the value, this one again, 7 into 10 to the power of 7 gram per mole. So 7 into 10 to the power of 7 gram per mole. So the value should be option A. So the answer is option A. Now the second question. Hydrated sulfate of a divalent metal of atomic weight 65.4 loses 45.85% of its weight on dehydration. So hydrated sulfate weight has been given. So metal sulfate, we don't know what is that metal. So MSO4 dot XH2O. We don't know how many X's are there. How many water molecules are there in water? We need to find what is X. 4, 5, 6, 7. Now, given atomic weight of metal is 65 point. This metal atomic weight given in the problem 65.4. Now, mass if you are calculating, so 65.4 plus sulfur 32 plus 4 into oxygen 64 plus 18x. H2O molecular mass is 18, so 18 into x, 18x. So we will get the value 161.4 plus 18x. So this is the value you will get it. Now mass percentage of H2O. Mass percentage of H2O if you want to find it. Now we have mass of H2O is there and mass percentage of H2O if you want. So here you are finding for H2O. So mass of H2O by mass of all the components. This is all the components. So 18x is the mass of water by all the components. Mass is 161.4 into 18x. So this is the mass percentage of H2O. Given mass loss is 43.85%, means that much weight loss is there. So obviously whatever this mass percentage is, that should be equal to whatever the mass lost during the reactions. So what you get if you solve for x? X is equal to 7. So we get x is equal to 7. So now you put 7 means x place. So you get the answer. Magnesium sulfate 7H2O is your answer. Next, question number 3. 10 grams of hydrogen and 64 grams of oxygen were filled in a steel vessel and exploded. Amount of water produced in this reaction is. Now both of them, hydrogen is a gas which reacts violently whenever you are doing a combustion reaction, for example in presence of oxygen. So it's got exploded in a steel vessel. Now you need to find how much amount of water got formed in with respect to moles. For that, what I am going to do, first of all, molar mass of hydrogen is 2 grams. Given weight is 10 grams. So how you will find number of moles of hydrogen? Given weight by molar mass. So I get the number of moles, 5 moles. Similarly, oxygen also weight has been given 64 grams. So now if I want to find the number of moles, what we need to do? 64 grams by each oxygen. Atomic number 8, mass number is 16. Since 2 oxygens are there, by 32 grams. So moles are 2 moles of oxygen is there in the given weight. Now formation of water. How the water form here? H2 plus O2 gives rise to H2O. Means 2H2 plus O2 gives rise to 2H2O. This is the balanced equation of water. If H2 is completely consumed, so 2 moles of H2 is reacting with 1 mole of O2 and we are getting 2 moles of water. If H2 is completely consumed, moles of H2O is, for example, 2H2O is giving 2H2 is giving 2H2O. 5H2, since 5 moles of H2 is there, we will get 5 moles of water. 5H2 gives 5 moles of water. Oxygen, if you take it, 1 mole of oxygen is giving 2 moles of water. 1 mole of oxygen is giving 2 moles of water. Now, if I take it oxygen, oxygen is 2 moles. Here I got 2 moles. So, 2 moles of oxygen will give how many moles? Just to double it. So 4H2O. Since 1 mole is giving 2 moles, 2 moles will give 4 moles. So which one is giving less amount of water? With, so your water formation is depend upon oxygen content. Here oxygen content is less and hydrogen content is more. So water, while formation water, oxygen is directing or controlling the formation of H2O. So O2 we call limiting reagent. So total how many moles of water is forming? 4 moles of water is forming. So your answer should be option B. Next question. This is the question from photoelectric effect. A plot of kinetic energy half mv square of ejected electron as a function of the frequency of the incident radiation for 4 alkali metals given below. We need to find what are those M1, M2, M3, M4 metals. Here kinetic energy has been given on y-axis and on x-axis we have frequency. Photoelectric effect. According to photoelectric effect, H nu is equal to H nu naught plus Ke, where H nu naught is work function phi. Now you are drawing graph for Ke versus nu. Now how that affects? Phi is work function. So H nu naught is equal to phi. If you want nu naught value 1 by h into phi means directly proportional to phi. Mu naught value directly proportional to work function. So work function, whenever the frequency is more, work will be more. So to remove the electron, for example, lithium, if you take it, lithium is smaller atom compared to other alkali metals. So removal of electron from alkali metal is difficult. Alkali metals in the sense here, lithium is difficult compared to other alkali metals. Reason because of smaller size, removal of electron is difficult. So we need to do more work. So we need to apply more frequency. So obviously this one will be having, lithium will be having more work function. So lithium should be having highest frequency. If you are moving left to right on the x-axis, frequency is increasing. So your M4 should be lithium. So size, if you take it from top to down, lithium, sodium, potassium, rubidium, cesium, francium. So here we have started the elements from rubidium. So rubidium should be having less work function and less frequency sufficient enough to remove the electrons because of larger size. From top to down, since each shell is increasing, size of the size of metals increases. Size of any element in the periodic table from top to down in a group increases. So your answer should be option B. The longest energy to break 1 mole of chlorine-chlorine bond in Cl2 is 242 kilojoules per mole. The longest wavelength of light capable of breaking CCl bond is. So light velocity has been given and number of Avogadro number has been given, and they are asking you to find the energy required to break 1 mole of chlorine-chlorine bonds. That already given 242 kilojoules per 1 mole is required energy. The longest wavelength of light, and we need to find lambda value. Longest wavelength means shortest frequency. Shortest frequency. Longest wavelength means least energy. How much energy is required to break chlorine-chlorine bond? How much least energy is required? So bond energy of a 1 mole CCl bond is 242 kilojoules per mole. For example, single bond if I take it, this is for 1 mole. For single bond if you take it, 242 by Avogadro number 6.023 into 10 to the power of 23 kilojoules. Now this one 242 by 6.023 into 10 to the power of 23. This value if you solve, we will get 4.017 into 10 to the power of minus 22 kilojoules. So this is the value we are getting. So energy is equal to what we know, hc by lambda. hc by lambda. Now energy E value is there, 4.017 into 10 to the power of minus 22. H value is Planck's constant, 6.626 into 10 to the power of minus 34. Light velocity 3 into 10 to the power of 8. Lambda value we need to find. So lambda value, if you solve in this problem, lambda value if you solve, we get lambda value 4.94 into 10 to the power of minus 7 meters, means 494 into 10 to the power of minus 9 meters, means 494 angstroms. So your answer should be 494. Sorry, for 10 to the power of minus 9 meters means nanometer. 10 to the power of minus 10 meters means that is angstrom. So this is nanometer. You can write nm. 10 to the power of minus 10 meters means that is angstrom. Answer is 494 nanometers. The next question. A ball of mass 200 gram is moving with a velocity of 10 meter per second. If the error in measurement of velocity is 0.1%, the uncertainty in its position is. So here this law is Heisenberg uncertainty principle. Mass has been given and velocity has been given and error in velocity also given. Delta x into delta p is greater than or is equal to h by 4 pi. So delta x into m delta v is greater than or is equal to h by 4 pi. So delta x I am taking directly equal to h by 4 pi into m delta v. I have sent on the right hand side. You can take it directly equal value now. So delta x is equal to h by 4 pi m delta v. So but error associated with the volume velocity given, delta v value is error. If you take normal value is change in velocity is 10 meter per second. Error given 0.1%. Error is 0.1%. Now if you take it delta v value, so after if you count this, if you consider this error also, 10 into 0.1 means 0.1 by 100. So the value should be 10 to the power of minus 2 meter per second. This is the delta nu value, original delta nu value after considering error also. So delta x, if I substitute all the values, 6.625 into 10 to the power of minus 34 by 4 into 3.14 into what's the mass value given is 200 grams. So 200 into 10 to the power of what the value we get, 10 to the power of minus 2. So you will get the value, if you solve this one, finally you will get 2.64 into 10 to the power of minus 32 meters. So this is the answer you should get, 2.64 into 10 to the power of minus 32 meters. The next question is, consider the following vessel of a dimension, given dimensions. Here cube has been given, sphere and cylinder. And if you take the volume of the cube, usually volume of the cube, a cube. So 10 to the power of 3. 10 to the power of 3 means 1000. Here 10 to the power of 3 centimeter cube. So 1000 centimeter cube. 1 centimeter cube is equal to 1 ml. So 1000 ml is equal to 1 liter. Here exactly you have 1 liter quantity. This 1 liter you are pouring in cylinder which is having 10 centimeter length and 10 centimeter radius. Now, but if you are adding that one to the cylinder, what should happen here? Now ions are solution contain H2SO4. Now cubical vessel is filled completely with 2 molar H2SO4 solution, whereas spherical and cylindrical vessels are empty. Then the total content of the cubical vessel is placed in cylindrical vessel. Total content we have poured in cylindrical vessel, and it is further filled completely with 1 molar barium chloride solution. Barium chloride and H2SO4 reacts. Whenever barium chloride reacts with H2SO4, we will get barium sulfate, which is a white precipitate. Precipitation reactions we have studied in 10th class. So molarity of sulfate ions in aqueous solutions will be, you need to find the molarity of sulfate ions. For that, volume we have calculated 1 liter, we got it. In 1 liter, how many moles of H2SO4? What we know, the relation molarity is equal to, we know that molarity formula, number of moles per unit volume. Okay, number of moles per liter, for example. Here, number of moles, if you want, molarity into volume. Here, literally, molarity into volume. So, molarity is 2 molar. Volume is, volume we got it, 1 liter. So, totally how many moles we got it in 1 liter? We have 2 moles of H2SO4. So H2SO4, if you take it, 1 mole of H2SO4 will give 2 H plus ions, 2 H plus ions and 1 sulfate ion. Now this equation suggests that whenever 1 sulfuric acid is dissociating, we are getting 1 sulfate ion. Here 2 sulfuric acid molecules are there, means we will get 2 sulfate ions, we get 2 sulfate ions, we will get it. Now volume of the cylinder, if you calculate, volume of the cylinder is pi r square h. So 3 into R value given, not D value. So I can substitute directly 10 square, height also 10. So 3 into, this is centimeter square now, this is centimeter. So 3 into 100, 3000 centimeter cube means 3 liters. So the volume of the cylinder is 3 liters. Now if you add this Q value, you will get like 1/3 position only. Since the capacity is like, this is 1 liter, but whole the capacity is 3 liter. This dabba capacity is 3 liter capacity, total capacity. Now we got the volume also. Can we calculate now barium sulfate? If you take it, moles of barium sulfate, how much is required? Here, cylindrical vessel, and it is further filled completely with 1 molar barium chloride solution. So the volume should be moles of barium chloride, 3 molarity, no? Molarity is 3 liter, that is for 1 liter molarity is 3. So moles are 3 moles. Moles are 3 moles. So 3 barium 2 plus ions are there, and how many sulfate ions are there? 2 sulfate ions are there. So sulfate ions are there less quantity, barium 2 plus ions are in more quantity. So obviously this one completely reacts since excess barium 2 plus is there. So leftover sulfate ion concentration is molarity of sulfate ions in aqueous solution will be, no, it won't be there, completely it got reacted since more barium 2 plus ions are there. So the answer should be 0 molarity. The next question, the radial probability distribution curve of an orbital H has 4 local maxima. So if you take it, probability density curves, 4 local maximas. The radial probability distribution curve. So the radial probability distribution curve means we get a graph like this. If you draw, now 4 local maxima means actually they touch the curve, they touch the whatever the axis, means how many nodes are there. Okay, like this we'll get graph. How many nodes are there touching? Actually, this touch this axis. 1, 2, 3 nodes are there. Whenever 3 nodes are there, and also the orbital has 3 angular nodes. That information has also given. 3 nodes are there. Angular nodes 3 means L value is 3. L value is 3 for which orbital? That is F orbital. So you can eliminate C and D. Answer should be F orbital. So A and B. Now, if you take angular nodes L values has been given, local maximus 4 has been given. Radial nodes, what's the formula? N minus L minus 1, that is equal to 3. Since 4 local maximas are there, radial nodes N minus L minus 1 is equal to 3 and N minus L is equal to 4. And also L value given, N minus 3 is equal to 4, so N is equal to 7. So N value we got 7 and L value is 3, means literally F. So your orbital should be 7F. Answer is option A. Next question. The radius of second orbit of lithium 2 plus is X. The expected radius of third orbit of beryllium 3 plus is. Radius Rn. Any orbital, if you take it, hydrogen like orbital, 0.529 n square by z angstroms. This is the radius for nth orbit. For second orbit of lithium 2 plus ion, lithium 2 plus n second orbit, if you take it, n is equal to 2, z value is lithium is 3. So you substitute that 0.529 3 square by 3 square by n value is 2. So 2 square by 3. No, that is value is x. So I am taking this value is x. Now the expected radius of third orbit of beryllium 3 plus. Third orbit of beryllium 3 plus you need to find. Beryllium 3 plus if you take it, third orbit. So n value is 3. Z value is beryllium fourth one. So radius of beryllium 3 plus single electron system. So 0.529 into 3 square by 4. 3 square by 4. So 0.529 into, so how we can correlate both the equations? So 2 square by 3 means 4 by 3. 4 by 3 value we got it. So shall I write it? 4 by 3 into 3 by 4. 3 3 cancel, 4 4 cancel. So you will get the same value only into 3 square by 4. Once again, I have just multiplied with the same value. There is no difference. Why? Because if I have this value, I can substitute x. I want to correlate both. So just I have multiplied into 4 by 3 and 3 by 4. So this value I can substitute x. Sorry, actually pen is having some 0.529 into 4 by 3 means I am just writing x. This value is 3 cubed by 4 into 4, 16 means 27x by 16. So beryllium of the radius of the beryllium, sorry, is 27x by 16. So your answer should be C. Simple. What value should be reported for the burette reading shown for a colored solution? Whenever we take colored solution, for colored solution, if you are looking through burette, the general rule, what's the general rule? To read the point on upper meniscus, whatever this shape we call meniscus, this shape is due to surface tension. Here molecules are being attracted from downward, so downward pull will be there. Here less number of molecules are there compared at the center, so pull is less. So we will get like whenever you fill liquids in vessels, you can observe the shape like with some meniscus we call. Whenever colored solutions, if you take it, and normal water like transparent solutions, if you take it, transparent solutions we always take lower meniscus. Colored solution we take it upper meniscus. This is due to the reading. For colored solution we are taking on the upper meniscus, which is most visible to the observer, which is this is most visible. Whenever colored solution if you take it, you can't identify uh, lower part. Why? Because color, whenever color is their solution, you can't see lower meniscus where it is touching the reading. So only we can see upper. Why? Because here opaque area, you can't see through this to find this exactly inside. If you are looking here and here, no difference. Why? Because since this is a colored solution, you can't see beyond inside. Here inside we can't see, this inside portion we can't see. What we can see, only we can see from here where it is touching. Here it is touching the reading, so that reading we will take it when our colored solution if you take it. That's why upper meniscus we will take, just to get the more accuracy. So the value is, this is 22, 22.1, 22.2, 22.3, 22.4. The value should be option C. The next question, equivalent weight of bromine in the following reaction. So bromine oxidation number, if you take it here 0, here if you take it bromine Hg2 plus means Br is in -1 oxidation state. Here oxygen -2, hydrogen +1, bromine +1. So bromine -1 +1, here 0. What we call simultaneously same molecule or same atom or same ion is getting oxidized and reduced simultaneously, means those kind of reactions we call disproportion reactions. Disproportion reaction. So we will balance the equation. 2Br2 plus HgO plus H2O gives rise to HgBr2 HgO plus HbRO. Now this one, if you take it here, how many electrons it's gaining? Okay, I'm just balancing by taking 2Br2. So Br2 plus here 1 Br, so 3 Br are there. So if I'm keeping here 2HBr, H2O, 2HGO. Now the equation is balanced. Here gain of 2 electrons. Why? Because each bromine is in 0 oxidation state. Here we got -1, 2 into -1 -2. So bromine is getting 2 electrons. Here loss of 2 electrons, gain of 2 electrons and loss of 2 electrons. Now n factor if you take it, for disproportionation reaction n factor is equal to 1 by n is equal to 1 by n1 plus 1 by n2, means 1 by n1 means oxidation n factor and reduction n factor, oxidation n factor and reduction n factor. Now if you take this one LCM n1 n2 n2 plus n1. So if I am taking n, just you take it inversion n1 n2 by n1 plus n2. This is the overall n factor for disproportionation reaction. So what we got? 2 electrons, gain of 2 electrons. So here we got 2 electrons simultaneously for one molecule here. Here if you take it, here 2, here 2. Overall number of molecules if you take it left hand right hand side completely balanced. So you can write it n factor 2 into 2 by 2 plus 2 means 4 by 4, that is 1. So now equivalent weight they have asked. They did not ask you what is n factor. Simply equivalent weight is what? Molecular weight by n factor. Molecular weight by n factor. Molecular weight is how much? Bromine is 80. Bromine is 80 means bromine Br2 is 160. 160 bromine molecule, if you take it, 160. 160 by n factor is 1. So answer is 160. You should have the answer C. The next question, ratio of stoichiometric coefficients of N2H4 to Cl minus in the following reaction. ClO3 minus plus hydrogen N2H4 gives rise to NO3 minus plus Cl minus. Now N2H4, if you take it, hydrogen, hydrogen here, hydrogen, hydrogen, hydrogen. If you break this bond, whenever if you break the bond between the same type of atoms, 0 oxidation state, 0. If you break this, +1, -1, +1, -1. So overall charge present on the nitrogen is -2. Nitrogen oxidation number, each nitrogen is -2. Overall is -4. For average is, for each nitrogen is -2 oxidation. Here chlorine is in +5 oxidation state, here -1. So chlorine is getting how many electrons? 6 electrons. Nitrogen here +5 oxidation state. Here it is -2. Means how many electrons is lost? 7 electrons it's lost. 7 electrons it's lost, isn't it? If you balance this N2H4 now, each nitrogen here left hand side only one N2 of H4 is there. Right hand side it should be 2 NO3 minus. So 2 into 7 means 14 electrons. One molecule is losing 14 electrons. So 14 is the n factor. Once again, loss of 14 electron in hydrazine, and you will get 2 nitrate ions. Since hydrazine is one molecule, n factor of hydrazine should be 14. So whenever we are balancing, n factor of N2H4 should be is the coefficient or moles of ClO3 minus. What is the n factor of ClO3? 6. So 6 into N2H4 gives rise to, okay, now after balancing we will get 12. Since 6 into 2, 12, NO3 minus plus 14 Cl minus. So this is the balanced equation. Now coefficients, if you take it, 14 and 16, hydrazine to chlorate ion. What's the ratio? Simple stoichiometric ratio, 6:14. Simplify means 3:7, but directly given 6:14. Answer should be option D. The next question is, in which triplet each species can an oxidant and reductant? When a species can oxidant, if it is in lower oxidation number, means still that can increase that oxidation number by donating the electrons. When that can be reductant, or what you can say, oxidant, the species which accept oxidant or oxidizing agent, which remove the electrons, are called oxidant or oxidizing agent. Reductant means which donate electrons is called reducing agent. So simultaneously if they're acting means your whatever the elements, they are not in the maximum oxidation state, neither not in maximum, not in minimum. Still that element can go to maximum oxidation state by releasing the electrons, by accepting the electrons that can come to minimum oxidation state. So here the cases, if you take it, HNO2, nitrogen is in, HNO2 means 2 nitrogen, 2 into -2, -4 +1, for hydrogen +1. So nitrogen is in +3 oxidation state, that can go to +5, and that can accept, nitrogen can accept electrons also, -3, since that can reach to until neon electron configuration, until filling the electrons. So nitrogen can act as both oxidant and reductant. Similarly, sulfur, if you take it, sulfur is in +4 oxidation state. Maximum can be +6, minimum can be -2. Here H2O2, if you take it, oxygen is in each oxygen is in -2 oxidation state. One oxygen is in -2 means that is normal oxide. Both the two oxygens are in -2 means each oxygen is in -1 oxidation state. Means then only we call peroxide linkage. So that can decrease to -2 and that can give even plus oxidation state also. For example, oxygen O2F2, if you take it, oxygen and fluorine bond is forming means fluorine will get negative charge, obviously oxygen will get positive charge, +1 or +2 based on the number of reagents, number of fluorine atoms attached to that. So here also that can act as both oxidant and reductant. So option B is your correct answer. The set of reagents. Triplet means 3 sets which can access set of 3 compounds which can access oxidant and reductant is option. Okay, the next question is consider 3 hypothetical ionic compounds AB, A2B, A2B3 where in all the compounds B is in -2 oxidation state and A has a variable oxidation state. B is fixed. B is in -2. A to B -2. B is in -2 oxidation state. A to B3 -2. Here -2 oxidation state for B. So A should be +2. Here B is in -2 means each A2 here whole that A2 should have +2. Here it should have +2 means each A will be in +1 oxidation state. Now A to B3. Usually whenever like these compounds are there, how we will find the charge here? We will just show that cross division or like cross multiplication we will show. Here A to B3, if you take it, 3 B's are in -2, so -6. Here 2 A's are there. So 2 A's are there, they should be in +6. So each A will be in +3 oxidation state. Okay, now what I'm going to explain here, they have asked each B is in -2 oxidation state and A has a variable oxidation number. Yes, what is the correct order of lattice energy of these compounds? What is lattice energy? The amount of energy required to break a solid compound into its individual gaseous ions, or the amount of energy released whenever individual gaseous ions are coming closer and there is some amount of energy while formation of a solid compound. That's one we call lattice energy. Whenever charges are more, attractions are more between cation and anion. So the magnitude of charges present on cation and anion plays a very crucial role for lattice energy. Whenever the charge is more, lattice energy is more. Which compound is having here the highest charge, magnitude of the charge? Lattice energy is directly proportional to magnitude of the charge. So A2B3 is having highest, then AB is having highest since +2 and -2. But here if I take it A2B, so here also +2 -2. But what happening? Each A is in +1 means contributors are more, charge is less. Contributors are more and charge is less. So you should have AB first compared to A to B. Why? Because there in AB contributors are less, but charge is +2 -2. But A to B, the number of atoms in A to B number of atoms are more, but the charge is less. So lattice energy is less overall. So you will get A to B lost. So where we can see this option, A to B3 is the first, both B and D, but clearly in B we can see A to B3 is greater than AB is greater than A to B. So your answer should be option B. Okay, the next question. Consider the following given reaction. Chromate ion is there, K2CrO4 or like Na2CrO4. Chromate ion is there, CrO4 minus aqueous. That one, if you treat it with silver nitrate, we are getting silver chromate. Means Az2 CrO4 2 minus. Here 2 minus is there, means silver, if you take it, silver usually in B plus P oxidation state. Since minus 2 means here plus 2 should be there. Means 2 silver atoms are required with each one with plus 1 oxidation state. So the formula should be Az2CrO4 silver chromate. So option A is correct, but they have asked for false statement. So this is not our answer. Now, if you take option B, the minimum mass of zinc required to reduce 0.1 mole of chromium 3 plus to chromium 2 plus is 6.54 grams. Chromium 3 plus to chromium 2 plus means chromium 3 plus ion is getting reduced. How many moles of chromium 3 plus is there? 0.1 mole. The minimum amount of zinc required to reduce. Zinc donates electrons. Zinc to zinc 2 plus reactivity series, if you take it, zinc is getting here reduced to zinc 2 plus, chromium is accepting those electrons. Now whatever zinc has given, that electrons only should be accepted by chromium. So equivalence should be same. Now if you take it, equivalence for chromium 0.1 into 1 is equal to weight. Now equivalence of zinc, if I take it, weight by equivalent weight. So weight by equivalent weight, if I take it, zinc atomic weight is 65.4. Each zinc lose 2 electrons. So 65.4 by 2. Both the equivalent should be same. So W, if you find it, weight of zinc required is 0.1 into 65.4 by 2. So the value we will get it 0.1 into 65.4 means I can write it 6.54 by 2 means 3 point, we will get it some value 3, but the value given as 6.54. So this is incorrect. 6.54 is not the given weight. So false. This is a false statement. So this is our answer. Now C and D, if you take it, the conversion of CrO4 2 minus to Cr2O7 2 minus is not a redox reaction. So we will check this. Chromium is in which oxidation state here? CrO4 2 minus means plus 6. Here Cr2O7 2 minus, if you take it, here also oxidation state of chromium is plus 6. So this is not a redox reaction. The statement is correct. So this is not our answer. This is not our answer. The equation Cr2O7 2 minus plus 14H plus 6 iron 2 plus gives rise to 6 iron 3 plus 2 Cr3 plus 7H2O. Correctly describes the reduction of Cr2O7 2 minus by acidified iron sulfate or ferrous sulfate. Now if you take this equation, if you balance this equation, okay, if you balance this equation, already balanced equation only, so iron 2 plus is getting converted to iron 3 plus. Now this is getting oxidized. The equation here, this is getting oxidized. So other element, whatever chromium, that is getting reduced from plus 6 to plus 3. Since this is a redox reaction, correctly describe the reduction of Cr2O7 2 minus by, yes, that is getting reduced. Cr2O7 2 minus is getting reduced. So the statement is correct. So this is not our answer. The next question. Which of the following process is exothermic? Exothermic means energy released during a process, whether that is a chemical reaction or a physical process. Nitrogen, if you take it here, N minus, nitrogen with atomic number 7 Electronic configuration is 2s2, 2p3. One lone pair, 3 single electrons. This is for nitrogen. Now n minus, if you take it, n minus means what? One more extra electron is there. Now one more extra electron is there. This is n minus. Half-filled orbitals are more stable. We know that half-filled orbitals are more stable due to symmetry around atom. In an atom, if electrons are symmetrically arranged around nucleus, that atom is more stable. So half-filled electrons are more stable. Px, Py, Pz. Three orbitals are having three single electrons. More stable. Here, one extra electron is there in n minus. So that can release that one electron and it will get half-filled electronic configuration again. So easily that can be released. One electron can be released out. You no need to give any energy. Electron comes out. Since this is unstable to stable state it is coming. Unstable will be having always more energy to less energy if it is coming from higher excited state to lower state. Means whatever the difference in energy, that should be released out. So this process n minus to n is an exothermic process. But n to n plus is already stable. For example, nitrogen, you have to apply some energy to remove the electron. So this process is not exothermic. Similarly, n to n minus, addition of electron is difficult. In this, you can't add the electron easily. That is not exothermic. Since stability you are disturbing, so you need to apply more energy to disturb that. So that process also endothermic. This is also not our answer. N plus 2, n2 plus. Already one electron lost. N plus, you are adding one more electron. One plus one electron lost means what will happen? Effective nuclear charge increases, so that attracts the remaining electrons more. So the second electron removal is more difficult. Always second ionization potential is more compared to starting one. Whenever in between there is no stable state like inert gases are there, that time it will change. Otherwise, effective nuclear charge increases with the charge. So this is also not our answer. Only answer is option A. Gadolinium with atomic number also has been given. Has how many unpaired of electrons? Gadolinium, we will take it. Lanthanum 57, cerium 58, praseodymium 59, neodymium 60, promethium 61, samarium 62, europium 63, gadolinium 64. So gadolinium 64, if you take it, electronic configuration of gadolinium, if you take it. So after 57 lanthanum is a d block element. Before that we have 56 barium, 55 cesium and 54 xenon. So after xenon 54, how many electrons are there? We will count it one by one. So electronic configuration of gadolinium, if you take it, 6s2, f orbital started. So inner penultimate shell, 6th period. So 6s2, 4f, 3d. Since after lanthanum, how many electrons are there? Lanthanum 54. After that, 6 plus 4. So 6s2 is the electronic configuration of barium. After that, you add the remaining electrons, whatever the electrons are there. So electrons are there. Okay, once we fill, we will get the answer. 4f7, 5d1, 6s2. So total electrons are 10. After 54, gadolinium is having 10 electrons. Gadolinium is having 10 extra electrons after xenon. So 2 plus 1, 3 plus 7, 10 electrons are there. So this is the orbital's electronic configuration. Now 4f7, if you take it, f orbitals are 7. 1, 2, 3, 4, 5, 6, 7. Each orbital will be filled with one electron, then only they pair up. D orbitals, if you take it, 3, 4, 5. Only one single electrons are there. 6s2 is filled, 2 electrons. So how many single electrons are there? We have total 8 single electrons are there. Each electron spin is half. So 8 into half. 8 into half is 4. So 8 single electrons are there and spin is 4. So your answer should be option C. The next question, following graph variation of ionization potential with atomic number in second period, value of ionization potential of sodium 11 will be. We know that left to right if you move, ionization potential value increases. Ionization potential value increases left to right because size decreases. With neon, filled electron configuration more stable, highest ionization potential in the each period. Inert gases will be having the highest ionization potential value. After neon, we have sodium. Now you tell me, lithium, if you take it, this belongs to second period. 2s1 is the electron configuration. Sodium, if you take it, 3s1, size is larger than lithium. Whenever size is larger, radius is more. So the amount of energy required to remove the electron will be less. Why? Because effective nuclear charge is less. Attraction between the nucleus and electrons is less. So that you can remove that valence electron very easily by applying less energy itself. So ionization potential, the amount of energy required to remove an electron from gaseous, inert, isolated atom, only we call ionization potential. To make ion, how much energy or potential you need to apply? Since lithium small size and sodium is larger size, sodium required less energy to remove the electron, and lithium, if you compare, sodium should be down below lithium. Lithium, if it is there somewhere here, once atomic number, if you take it 12, but that peak has to come down. Again, that increases, like magnesium, aluminum, like that. Aluminum half filled, so stable, removal will be difficult. But compared to boron, aluminum will be less because size is more. Ionization potential value of aluminum will be less than boron. So below lithium, option A is correct for 18th question. Then match the following. So not uncorrected one, this paper. ICl4 minus sp3, dsp2, sp3d or sp3d2, which hybridization it is. So whenever hybridization, if you take it, iron, here iodine given, iodine halogen, so 7 valence electrons, 3, 4, 5, 6, 7. 1 electron is there. So 8 electrons are there, 4 chlorine atoms are there. Chlorine monovalent, so 4 chlorine atoms. Total 4 electrons are there. Since they are not involving any reactions, they exist as lone pair. So 2 lone pair, 4 bond pairs, total 6 electron pairs. 6 electron pairs are there, means what's the hybridization? sp3d2. So ICl4 should be sp3d2. Now TeCl4, MnO4 minus, we will see manganese, total 7 plus 1, 8 electrons, 3, 4, 5, 6, 7, 8. How many oxygens are there? 4 oxygens are there. Oxygen is a divalent species. So simply we can calculate total 4 sigma bonds are there. This is sigma, sigma. Whenever oxygen is forming double bond, means one bond is sigma bond, other bond is pi bond. Sigma bond only decides the structure. Total 4 electron pairs are there. Pi bonds we won't consider, like whenever for hybridization, they won't decide the structure. Only sigma bonds decides the structure. So manganese, if I take it, 4 electron pairs are there. Hybridization should be sp3. where it is sp3 here for permanganate ion. Now nickel tetracyanide power 2 minus in power and TeCl4. You will check one by one. Technetium, sorry, this is tellurium, oxygen family, oxygen, sulfur, selenium, tellurium, polonium. Now tellurium valence electrons like oxygen 6, 1, 2, 3, 4, 5, 6 valence electrons. How many chlorine atoms are there? 4 chlorine atoms are there. So 1 lone pair, 4 bond pairs, total 5 electron pairs are there. Isn't it 5 electron pairs are there? 5 electron pairs are there means hybridization should be dsp2 or sp3d. dsp2 means only 4 electron pairs are there. sp3d means 5 are there. So 5 electron pairs are there means hybridization should be sp3d. Now NiCN4 2 minus, nickel, if you take it, nickel atomic number 28, nickel 28, electronic configuration is 3d 8 4s2. But nickel is in which oxidation state here? Nickel plus 4 into minus 1 is equal to minus 2. So nickel is equal to minus 2 if I minus 2 plus 4. So nickel is in plus 2 oxidation state. 1, 2, 3, 4, 5, 6, 7, 8. 2 single electrons are there with nickel. This is 3d6, 3d8, 4s2. After argon, 10 electrons are there. So 3d8, 4s2. Now that is nickel 2 plus means oxidation number. Nickel 2 plus means 4s0. Panel outside shell, valency shell, lose electrons. So remaining electrons 1, 2, 3, 4, 5, 6, 7, 8. 8. And 4s started means d orbital also will be available. Whenever cyanide ion is coming, cyanide Cn minus, nickel is at center. 4 Cn minus ions are coming to the nickel. Nickel is at center. Since cyanide ion is coming, that negative charge is there with the carbon. Carbon cannot pull the electron density, so the density is like spread across over a larger area. Once Cn minus is approaching nickel, that Cn minus electrons repels the nickel d orbitals electrons, so that those electrons, because of electron-electron repulsions, they got pair up. They got pair up, and we get 1, 2, 3, 4. Since electrons got paired up, this electron got paired up, and empty d orbital, empty s orbital, empty d orbital. So ds, so this is after s, p orbital. This is p orbital. Since 4 cyanide ions are coming, cyanide ion give the electron here, Cn minus 4 electron pairs. So hybridization should be dsp2. dsp2. This is not involving. No fifth cyanide ion is coming. So only 4 are coming. Hybridization is dsp2. This one hybridization is dsp2. This is this one. sp3d is this one. So your answer, just according to your mark it, 1d, where it is, or you can say a is 3, here 3, here 3, b is 4, b is 4, b is 4, c is 2, c is 2, c is 1, d is 1. So your answer should be option D. The next question, the successive ionization energies for an element A are follows. Ionization energy IE1 here, an element you have taken, from there you are removing the electron and you are getting an ion. From there once again you are removing the electron, second electron, and you are getting A2 plus and IE3 3 plus. Remember, whenever you are removing the electron, effective nuclear charge is increasing because of less electrons, more protons. Protons attracts the outside electrons very strongly. So now the removal of second electron will be very difficult. So IE3 is greater than IE2. IE2 is greater than IE1, or IE1 is less than IE2 is less than IE3. Now this value should be highest, this value should be lowest. Highest, if you take this 3. So this is IE1 is lowest 27 kilojoules per mole. IE3 is 51 kilojoules per mole. So IE2 should be in between IE1 and IE2. So 27 and 51, which value is there? This is below 27, incorrect. B is there 33 with the value between 27 and 51. C more than 51, incorrect. More than 51, incorrect. So answer should be option B. Which of the following compound is not isomer of others? So isomerism means what? Iso means same, mers means part. Same chemical formula but different physical and chemical properties are there, means we call isomers. Here carbons, if you count, how many carbons are there? 1, 2, 3, 4, 5, 6, 7, 8. C8. Okay, how many hydrogens are there? In every place we have hydrogen here, hydrogen. Since carbon valency is 4, it can form 4 bonds. If no bonds are there, there hydrogens are there. You need to show. Here already 3 bonds are there. So if you fill total out of 8 carbons, 2 carbons having only 2 hydrogens. So total, if I count here, 2, 4, 6, 8, 10, 12, 13, 14. Hydrogens are there, 14. C8, H14. This also, if you count 4 plus 4, C8. Hydrogens, if you take it, 2 hydrogens here. So 1, 2, 3, 4, 5, 6. 6 into 2. 12 hydrogens. Here hydrogen, here hydrogen. So 14. So both are having same chemical formula but different structure. So isomers only. Now here if you take it, hydrogen, hydrogen. Total how many are there? 1, 2, 3, 4, 5, 6. 6 into 2. 14, 12 hydrogens are there. Carbons if you take it, carbons, 5 carbons, 3 carbons, 8 carbons. So C8, here 1 hydrogen, 1 hydrogen. Since out of 4 bonds, you need to show the 4 bonds. So total hydrogens are 14. Now this compound if you take it, how many total carbons? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 are there, C8. But hydrogens will check it. 1, 2. Now this is the 1, 2, 3, 4. So 4 into 2 hydrogens, 8 hydrogens. 8, 9, 10, 11, 12. So hydrogens are there 12. Means here you have to show the one more hydrogen. Hydrogen. H12 only are there. Means this is having different chemical formula. So option D is not an isomer of remaining compounds. So answer D is our correct answer. Next, mention the correct relationship between 1 and 2. Here a biphenyl compounds has been given. These biphenyl compounds are having different substituents. Bromine, 2 bromine atoms are there. 2 SO3 hits, sulfonic acids, functional groups are there. 2. Similarly, same. Only the difference between the 1 and 2 is chemical formula is same. Chain isomers means Whenever you take normal straight chain compounds and some branched chains, we call both are having different chains, chain isomers, but these are not chain isomers. Option A is incorrect. Option B, positional isomers. Only the position is different. If you take it biphenyl 1 2 3 4 5 6, so here sulfates, sulfonic acid and bromine is at 2 comma 6, but here they are in some other position, 3 comma 4. So positions are different. So 1 and 2 are positional isomers. Identical means same. No, they are not same. Positions are different. Positions of functional groups are different. Stereoisomers, no, arrangement of atoms in 3 dimension. No, we are not talking about this. Just position of atoms are different. So the answer is positional isomers. Next, which compound below is capable of showing geometrical isomerism? Now, this is like Damruk. So what happening here? Two chlorine atoms are there. These two chlorine atoms arranged on a spiro compounds like spiral binding, chain. They can be twisted like chain. How that rings will be there in a chain, like round. So spiral binding, how that spiral will be there. So we call this type of compounds as spiro compounds. Since they can be rotated after rotation, easily they can be rotated and there won't be any difference, no? So they are not geometrical isomers. When we call geometrical isomers, whenever a change is there, once you rotate, dipole moment will be different, physical and chemical properties will be different. So you can't rotate. For example, double bond is there, you can't rotate them. So A, B, C, D, if I take it, one C is here means one type of property, D is here means one type of property will be there. So that's how cis trans isomers will come. Option A is no geometrical isomers, B is no geometrical isomers, C and D if you take it. So I will open some visualization. So I made solutions also and I will share it in the website. Whoever interested, you people can go through that. Yes, Allenes we call whenever consecutive double bonds are there here. Consecutive double bonds are there, allene functional group. Two double bonds are there. So carbon is having two pi bonds, two sigma bonds. If carbon is having one sigma bond and two pi bonds, hybridization is sp. Only two sigma bonds are there. Hybridization is 180 degrees with bond angle. Hybridization is sp. So hybridization here at the center is sp. We know that p orbitals, if you take it here, hydrogen methyl group, this is the carbon double bond, means this is a pi bond, and here also a pi bond is there. Now sigma bond, already these orbitals got utilized. These orbitals cannot be utilized with this carbon, same orbitals, same direction. So what happens? Center carbon, two sigma bonds are over, pi bonds are two. This is one pi bond, this is another pi bond. So carbon, third carbon, if you take it, third carbon arranges such that empty orbitals of, since this is sp2 hybridization, this carbon, so this is like 120 degrees, sp2 hybridization 120 degrees. Here hydrogen, here methyl group, that only I have shown hydrogen, this is the methyl group. So this is 120 degrees lying on this book, on your book or the screen, but this is like not lying on the screen. This carbon is on the screen, this hydrogen is backside your screen, this methyl group is above the screen towards you. So if you take it, this plane below the screen and above the screen, and this plane, both are perpendicular to each other, when we can call geometrical isomers, whenever the atoms are in same plane, then only geometrical isomers, since planes are different, perpendicular to each other. So whenever allenes are having two double bonds, even number of double bonds, they won't exhibit geometrical isomers. Simple rule. Option C is incorrect. Option D, if you take it. Option D. Here also we have double bonds, consecutive double bonds. How many double bonds are there total? 3 double bonds are there. So allene, same allene if I am writing, carbon, one double bond, this carbon, double bond, this carbon again, double bond, and last carbon, hydrogen and methyl group. Now you take, this hydrogen is below the plane, this is above the plane. Now this carbon, if you take it on the plane, double bond on the plane, on the screen. But this bond is above the screen, below the screen. Again, this bond is on the screen. So total 4 carbon atoms with 3 double bonds. And here if you take it, they are coming hydrogen backside, one time, methyl group front side, front to the screen. So now methyl groups are there on the same side, above the screen. Hydrogen below the screen. Since same type of atoms are on the same side, means we call cis. Since this is a, so you can call this is as a cis isomer. Now, if this hydrogen got shifted here, that compound is different. It won't get shifted. Double bonds can't be rotated. If this hydrogen exists here, all the properties will change. That's why we will consider like two different compounds. If properties are not changing, we won't consider like different compounds. Hydrogen is here, methyl group is there backside. So this methyl group and methyl group are trans to each other, opposite side. This hydrogen opposite side, we call trans. Same side, above the plane, below the plane, cis. So option D can exist as geometrical isomer. Your answer should be option D for 23rd question. 24th question, they have asked IUPAC nomenclature for this compound. Whenever you take compounds like this, you will get the confusion from which position you have to count the longest carbon chain. How many carbon chains are there? Then only we can give the name. One, sir, why you have taken from this side? You can take it from any side. Thing is like substitution should have lowest number. Okay. If I am moving from left to right, I will give for example 1, 2, 3, 4, 5, 6, 7. Total 8 carbons are there. There is no doubt. You can show this also 6, 7, 8. Why we have taken this one as the main chain? Means here more substitutions are there, but here no substitution is there this side. More substitution things we have to take it as the longest chain, on the longest chain. Now why we are counting right to left or left to right? I will give that. Now if you take a substitution, this is at 4th position, 5th position, 6th position. Now if I add all these positions, lowest sum should be there always. 4 plus 5 plus 6. Substitutions are there at 4 plus 5 plus 6. So 15. Now from right to left if I take it, 3 plus 4 plus 5. What's the value? 3 plus 4 plus 5, 8 plus 5, 13. So the value is low. Substitution should have always lowest number. So that's why we count it from right to left. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 are there means carbons oct. 1 means meth, 2 means eth, 3 means prop, 4 means but, 5 means pent, 6 means hex, 7 means hept, 8 means oct. Octane. Octane is the root word oct. Single bonds are there all octane. Now substituents we have to take it. Third position methyl. Third position we have methyl. Fourth position, ethyl. This is propyl. Fourth position, propyl. 1, 2, 3, 4, 5, 6, 7, 8. We'll check the question, what they have given. So the given question is, okay, the IUPAC name of the following hydrocarbons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, as I told you, so the lowest sum should be there. 1, 2, 3, 4, 5, 6, 7, 8. Now, ethyl group is at 5th position. Ethyl group is there at 5th position, and methyl group is there at the 3rd position, and 4th position propyl group is there. Propyl group is there. Propyl, ethyl. E, P, M if you take it. Which one will comes first? E comes first. E comes first. So you can take it ethyl as the first. While writing alphabetical order you should write. So you should get the answer 5 ethyl, 3 methyl. Whenever you are writing numerical between the words, you have to write hyphens on both sides. Next, 4 propyl, 4 propyl octane. 5 ethyl, 3 methyl, 4 propyl octane. Now the next question, what is the IUPAC name of the following compound? As I told you, here 2 rings are there. If 2 rings are joined by single carbon atoms, means we call spiral compounds, spiro compounds. So this is a spiro compounds. Whenever spiro compound is there, we will count the substituents. You take it any side, 1, 2. So 1, 2 methyl group, CH3 group, 1, 2 dimethyl, 1, 2 dimethyl, and that is a spiro compound. Here options are there, B and C, spiro compound. Next, rings we have to count. Attached to this carbon, how many rings are there? 1, 2, 2 carbon atoms are there here in this ring. Here how many are there? 1, 2, 3, 4, 5 are there. 5 are there. So 2, 5. 2, 5. 2 carbons are there. We have to write the first smallest ring first. So 2, 5 octane. Total carbons, if you count it here, total carbons 1 in the rings I'm talking, 2, 3, 4, 5, 6, 7, 8 octane. Octane. So your answer should be 1, 2 dimethyl spiro 2, 5 octane. That is your answer. I hope this is very helpful. So I'm closing session. If you have any doubts or queries, you can comment below the video. We will try to respond promptly within the time. If you need any help beyond that, means you feel free to contact us at any time. Thank you everyone.